Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad Nakib bin Azharif and my partner is Saya Ong Wei Sheng from Group 6. We present about our mini project with the title Design of Smart RFID Transportation System. Okay. In our presentation today, we will cover overview, introduction, methodology, experiment setup, results, discussion or observation, conclusion and feature works. Introduction. RFID systems speed up the process of sorting parcel as it can read up to 300 text per second compared to conventional barcode. Why? Is to reducing the manpower is effective to prevent the spread of COVID-19. And the objective for our mini project is to combat COVID-19 and quicken the parcel handling process. Okay. Methodology. RFID tag placed on goods when enter the warehouse, then the goods processed at the warehouse. When the goods entering the warehouse, RFID reader will scan all the goods in the truck and the list of goods containing RFID will pop up in the computer or software inside the warehouse. Okay. Recognition of need in transportation. Then we generate the idea for circuit and discuss the most suitable circuit and we modify and construct the vanilla circuit. Then we test the circuit on Arduino Uno. Is the circuit working? If no, we troubleshoot and make some modification and then once again we test the circuit on Arduino Uno. But if the circuit is working, we record the RFID code and we draw the schematic and propose circuit. Next, we will finalize coding for RFID sensor to read RFID tag. Then we will test the circuit. If the circuit working, we will make if no, we will troubleshoot and make some modification. Then we will test the circuit again. But if the circuit is working, we will build the prototype and write the report and carry out presentation. And so how our project will functioning, the RFID sensor will detect the IO tag and send the signal to Arduino Uno. If the signal is correct, the blue LED will light up and the result output to Excel sheet. If it's wrong, the blue LED does not light up. So this is the list of hardware component we use in our project. So this is micro USB, breadboard, wires, RFID tag, LED, RFID reader, Arduino Uno, resistor, and buzzer. So for software, we use Arduino IDE, PLX-DAQ, Multisim, and Proteus 8 Professional. I think that is all for me. So I will let my partner Isaiah Ong to continue our presentation. Thank you.
So now I'll talk about the experiment setup of our circuit. So first we use the Proteus 8 Professional to set up. So this is the Arduino board, this is the buzzer, these are resistors, LEDs, virtual terminal, that is COM pin. So this one is this COM pin is generally to connect the physical RFID module to the virtual one, which will be shown in the software here. However, since we don't have a USB port that connects the RFID tag directly to the computer, so we have to transfer all these connections to our physical hardware setup. So as you can see, it's the same as the one here. There's buzzer, the LEDs, Arduino board, and the RFID module. So when the correct cut has been detected from the first part of the previous video, the blue LED lights up. Also, the buzzer will also light up. So these two components will help to notify the user that the correct cut has been detected. When no cut or the wrong cut has been scanned, the yellow LED will continue to light up and the blue LED and the buzzer will not sound. So this cut actually represents the RFID tags that will be placed on the parcels. As you can see on the left hand side of this screen is a COM tree. This COM tree is a serial monitor. For UID tag 37DD13AF, the message will output parcel detected, while for another UID tag 5EDC8CBA, the message will output wrong parcel. However, this part is not so user-friendly as it only can be accessed if the user has the Arduino IDE code software. So we decided to output this data to an Excel sheet using PLX-DAQ software, which is a data acquisition for Excel. Hence, it will enable the user to have easier documentation of all this data for the company. We also face some implementation challenges. The RFID LC522 module is not available in the Proteus 8 Professional because it requires a USB port that connects directly to the RFID tag. We don't have it, so we have to use the physical hardware. Then soldering equipment was also not available to us, hence we need to use self-in tape to connect this RFID LC522 module to our jumper wires. In conclusion, by using this system, less manpower will be required for parcel handling, which enables the practice of social distancing. In addition, searching of parcels without physical touch prevents the transmission of COVID-19, as COVID-19 can be transferred by touch of objects that have been contaminated with COVID-19 virus. Next, higher accuracy compared to conventional mode of reading, as conventional mode of reading requires a person be in the line of sight of the reading material. For future work, we can create a coding to get parcel data from user. As we know from our current project, the user has to key in the data manually into the Arduino IDE coding. Next, by placing RFID tags throughout the warehouse, this enables one system to control multiple RFID tags at one time. By including a Wi-Fi module also, workers can now work from home, which is effective to prevent the spread of COVID-19, as it can further reduce the number of workers at the warehouse. So that's all for our smart RFID transportation system from Group 6. Thank you for your time.